Hello, AP Stats students. This is Mr. Hazelhorst coming to you live from room A08. We've got our Chapter 2, Section 2B video today. We're going to talk about density curves and normal distributions, but specifically how to do calculations with a normal distribution. So if you've got your graphing calculator with you, you can pull that out. I'm going to use that as a reference and a resource today. And also if you have your ebook or your textbook, we're going to pull out a reference there as well as we do some examples today. But let's jump right into it. The first thing that we need to talk about today is what's known as the standard normal distribution. And the key to the standard normal distribution is that it's a normal distribution with a mean of 0 and a standard deviation of 1. Okay? So we get this basic shape that you see here, our standard normal bell-shaped curve. Again, the mean is in the center, which in this standard curve is always going to be 0. And then we've got our standard deviations moving out to both the left and right side. All right. Now, the key to the standard normal distribution is that all normal distributions are the same if we measure in units of size from the mean. So what that means is if we apply the z-score formula, our standard score formula, and we take whatever value we have and we change it to a z-score, that means we are now working with a standard normal distribution. All right? And this is really important because as we work with a normal distribution, ultimately what we want to do is we want to find area under a curve. Now, for those of you who are also in calculus, you know that's a lot of what you're going to do in calculus is you're going to find areas under a curve. Now, in stats, we don't have the calculus background to apply the calculus techniques to find area under the curve. What we need instead is we need to standardize it so that we can utilize the work that somebody else has already done with regards to the calculus of things. And that's where your textbook and calculator can come in. All right. So what we're going to utilize are what are known as a standard normal table. All right. So if we take a set of data, and we change it to its standardized values, right? Somebody's done the calculus for us and summarized all the areas under a curve in a normal distribution into a table, okay? Now, this table can be found in your ebook on page 935 and page 936, all right? If you've got your hard book, it's just towards the back. So I'm going to pull up my ebook here real quick so you can take a look at Table A, and then we'll talk through how we actually use Table A, all right? So here's my ebook, and here is Table A. This is, let's go back a page here. So here's page 935 in your ebook, all right? So notice all that has been done here is just a list of numbers, okay? The key thing that we want to notice here, though, is notice that we're utilizing the z-score to determine what value we pull from that table, all right? And we have one page of our chart to utilize with negative z-scores, and we have another page of our chart that works with positive z-scores. Now, the thing that I need to point out about both of these charts is look at the diagrams at the top, okay? And so if I read this heading here, it says the table entries, all right, whatever number I pull from this chart is the area under the standard normal curve to the left of z. Right, so if we look at the picture here, right, positive z-scores would all be above the mean, so they're going to be in the upper half of the data. All right, but again, we're shaded to the left. If I look at my negative z-scores, right, same picture, same title, again to the left of z, but again, now we're in the lower half. But the key that we need to remember here, again, is that this table represents all values to the left of z. So let me pull my PowerPoint presentation back up here. So let's show you an example of how we can utilize this table, all right? So suppose we want to find the proportion of observations from the standard normal distribution that are less than 0.81, all right? So that would correspond with to the left of, right? Less than to the left of, same thing, right? So in kind of mathematical notation, we'd say, okay, what are the proportion P of z values less than 0.81, okay? Now that 0.81 is important because that tells us exactly what we're going to look up in the chart, all right? So the whole number and the tenths unit tell us which row we're going to look in on the standard normal table, and the hundredths place tells me what column I'm going to be in. All right, so you can see 0.8 and 0.01 the intersection of that row and column are the value that I would pull off of the chart. All right, so according to this, 79.1% of our entries in the standard normal distribution will be less than a z-score of 0.81. Okay, so it's pretty easy for us to utilize this table, and most of you won't actually use the table. I'm going to walk you through today how you can also use your graphing calculator. All right, but we needed to introduce that table to begin with. So what we're going to do here through the rest of our video is I want to look through 3 examples and talk about, okay, what is the process? How do we do these standard normal calculations? And I think you're going to find this process to be relatively easy. Okay, so let's start out with some steps that we need to follow. All right, so we're going to talk about how to find areas in any normal distribution. Okay, so we've got a 3-step process that we're going to follow. Step 1 is we always want to state the distribution and the values of interest. And what I'm going to expect to see, and we'll see this in some examples here, is I want to see you draw a picture of our normal distribution. I want to see you label the mean and the standard deviation and any boundary values that we're trying to find information about, right? So that's step number 1. Step number 2 is we're going to perform the calculations. And you're going to have 2 options, all right? You can use that standard normal table, table A, in your book, or you can use the normal CDF command that's programmed into your graphing calculator. And I'll show you how to use that in our examples, okay? As we work through our examples today, I will do both the table and the graphing calculator so that you can see both. But again, you're going to get to pick which one of those you want to do. And then our last step is answer the question, all right? Answer whatever they asked us in that problem. All right, so let's jump into some examples. So here we go. All right, in a recent tournament, tennis player Rafael Nadal averaged 115 miles per hour on his serves. Assume that the distribution of his serve speeds is normal with a standard deviation of 6 miles per hour. All right, about what percent of Nadal's serves would you expect to exceed 120 miles per hour? All right, so the first thing that we need to do in this problem is we need to draw a picture. All right, so let's do that here real quick. So I'm just going to simply sketch a normal distribution. All right, so there's my bell-shaped curve. It doesn't have to be perfect in shape. But then again, I want to label any information that relates to this problem. All right, so first off, I'm going to recognize I have a normal distribution with a mean of 115 and a standard deviation of 6. So I'm going to use that normal distribution notation we talked about the other day in class. All right, then I'm going to draw the mean in the middle. Well, the center of this distribution is 115, and that gives me a reference point to draw off of with regards to any other numbers. Okay? So now I can get to the information that I was actually asked about, right? We want to know what percent of Nadal's serves exceed 120 miles per hour. Well, I know 120 is larger than 115, so I'm going to put it up here somewhere. I'm going to label it. And now I want to shade the area that I'm trying to find. Well, I want to find the percent of Nadal's serves that are going to exceed 120 miles per hour. So I want to find this area up here. Okay? Well, now we've got 2 routes to go. So let's start out, all right, how would we do this using the table? Okay? Well, the first thing that I would need if I'm going to use the table is I need the z-score. All right? That's what I have to look up on my table. So if we calculate our z-score here, we've got a value of 120. We're going to subtract the mean of 115, and our standard deviation was 6. So this is going to give us a z-score of 0.83. All right, so now at this moment, I need to pull my chart up. So let me pull my book back up here. And I want to be on the positive chart. And I want to find the intersection of 0.8 and 3. So we can see that that gives us a area of 0.7967. Okay? Let's go back here. All right, so again, that gave us an area of 0.7967. Now, what I need to remember is that this number, 0.7967, represents everything to the left of our z-score. Well, in this problem, I want things to the right. Okay? What do you remember about a normal distribution? Right, it has a total area of what underneath it? Well, hopefully you just said 1, right? So if I know there's 0.7967 to the left, all I need to do is subtract that value from 1, and that will tell me the area underneath the curve to the right, which would come out to be 0.2023. All right? So we could say that approximately 20% of Nadal's serves will exceed 120 miles per hour. Okay? Now, again, that's how we utilize these problems on our table. Let's talk about your graphing calculator. Okay? If you want to use your graphing calculator, we're going to use the normal CDF command that's built in. Okay? Now, I'm going to write out the work first, and then we'll pull up our graphing calculator and we'll actually type it in. Okay? Now, remember on that previous slide, it said show your work. So if I'm doing my problem with the table, here's my work. All right? Here would be my work if I'm going to utilize a graphing calculator. All right? We're actually going to write out the command. So I'm going to utilize the normal CDF. And then there's 4 values that we have to input into our graphing calculator in order for our calculator to run the correct calculation. All right? The first thing that we need to give our calculator is the lower bound of our shaded region. Okay? So when I look at my table up here, 120 is the lower bound of my table. Then I need to give it an upper bound. All right? What's the maximum? How high do we want to shade to? Now, when I look at this normal distribution, right, we're shading the whole rest of it. All right? So I just need some ridiculously high number, all right, to represent the upper bound. So let's say the maximum of Nadal's serve. Again, I want some ridiculously high number. Let's say it's 1,000. All right? So I'm going to go from 120 miles per hour to 1,000 miles per hour. Now, we know Nadal can't touch 1,000 miles per hour, but again, we just want to get close to that, some ridiculously high number. All right? Then we also need to give the calculator the mean and the standard deviation. So it will always be in that order. All right? Lower bound, upper bound, mean, standard deviation. So let me pull my calculator up here. And let's go ahead and input these values. Okay? Now, to access the normal distribution, we're going to go into our distribution menu, which is written above the VARs button. So if you look over underneath your arrow pad, so if I hit second and then the VARs button, you can see we pull up, right, this list of distributions. Okay? And what we're going to utilize today is number 2 in the list, the normal CDF. Now, my calculator lists out in detail what I need to input. For those of you with the TI-83 calculator, you're just going to type in exactly what I've written in red in that order and use the comma button, which is above the 7, to separate it. Okay? So my lower bound, again, I said, well, that's going to be 1,000, or excuse me, my lower bound is going to be 120. My upper bound is 1,000. My mean is 115. And my standard deviation is 6. So I'm going to go ahead and hit paste. All right, this is what, if you have a TI-83, it should look like if you've typed it in. And then I'm just going to press enter. All right, and you can see our calculator gives us a percentage of 0.2023, which is right on. Well, I got a typo over here. This should be 2033. But that is very, very close to what we found through the table. Okay. So again, on these normal distribution problems, you're going to get a choice of whether you want to use your table or you want to use the actual calculator. All right? So let's take a look at another problem here. All right, let's say now we wanted to find the percent of Nadal serves that are between 110 and 100 miles per hour. Okay? Now in this problem, again, we want to sketch out the normal distribution to start. All right, so again, we've got a normal CDF with a mean of 115 and a standard deviation of 6. We have our mean of 115. All right, we want to find the percent of his serves between 100 and 110. So this would be our shaded region that we want to utilize this time. Okay? Now again, if I wanted to do this utilizing the table, I could. I need to convert both 110 and 100 into z-scores and look them up on the chart. But in this problem, I'm just going to use the graphing calculator because I'm assuming that's what most of you are going to do. It's a much faster process. So let's just type out, or just write out, what our normal CDF command would be in this problem. All right, so we go normal CDF. Our lower bound in this problem is 100. Our upper bound is 110. We have a mean of 115 and a standard deviation of 6. All right? So if we pull that calculator back up, let's change those input values here. So again, I'm going to go into my distribution menu. We're going to choose number 2. And now I need to change my bound. So my lower bound is now 100. My upper bound is now 110. I still have the same mean, the same standard deviation. I hit paste, press enter, and we can see that about 20%, again, of Nadal's serves are between 100 and 110 miles per hour, which ironically is about how fast I drove to school this morning. Just kidding. All right. Okay, so there's our second example problem. Now let's do one more here. All right, one more unique type of problem that we need to take a look at. Okay, so let's say now the question is we wanted to find the third quartile of Nadal's serves are faster than what speed? Now, if we're observant here, we'll notice this question has changed considerably. All right, the question is not what percent, it's now what speed. And instead of giving us a speed, they've actually given us a percent, right? We're talking about the third quartile. So if I take and do the same thing here, if I draw a picture of this problem, right? So we've got this normal distribution. Again, we still have a mean of 115, and we still have a standard deviation of 6, right? So we still have 115 hanging out here, right? But now it kind of gets tricky because I don't know what the speed is. Now, a little logic tells me I know that that speed is going to be above the mean because I'm in the third quartile, right? But I don't know what that speed is. Now, what I do know, since it's in the third quartile, is I do know that this area to the left of whatever the speed is, that area would be 75%. Because again, I'm in the third quartile. So you can see we have a much different problem here. We're almost given the exact opposite information. Instead of being given a speed and asked to find a percent, we're now given a percent and asked to find a speed. Okay? So we need a different set of steps to work through this type of problem. All right? Now, they're really essentially the same. All right? We're just going to go backwards in essence. So we start out again by drawing a curve, all right, and recognizing that we have an unknown boundary value, but we can still label it based on the percent that we're giving. We have a good idea of where it would fall. All right, step number 2, again, we're going to perform our calculations. And again, we want to show our work. Now, just like our other problems, you have the choice. Do you want to use table A, or do you want to use the inverse normal command programmed into your graphing calculator? Now, again, I'm going to make the assumption that most of you are going to use your graphing calculator. And so we'll work through that in our example here. And then finally, we answer the question. All right? So let's go back to our problem here. Let me redraw the picture real quick. All right? So again, we got 115 in the middle. We don't know what this boundary value is, but we know that we have shaded 75% of our data to the left. Okay? So this time, if we want to utilize our inverse normal command, all right, again, we're going to input some values. Let me talk through the values that you need to input here. So if I'm going to use my inverse normal, all right, instead of using an upper and lower bound, I just need to give it the percent to the left. All right, so we want 75%. We want to represent that as a decimal. All right, so 75% of our data is going to be to the left of our normal distribution, or excuse me, our z-score. All right, we have a mean of 115 and a standard deviation of 6. So this is going to be my input command. Now, let me pull my graphing calculator up and walk you through how that works. So again, we're going to go into the distribution menu. So second vars. Now notice, third one down is we have this command inverse normal, and that's what we want to put into our screen. Now again, on my 84, it's going to ask us for those input values. What's your area? And when it's asking area, it specifically means to the left. So I need to input 0.75. My mean, still 115, and my standard deviation is still 6. So I'm going to hit paste. Now again, if you have a TI-83 calculator, this is what your input is going to look like. We go ahead and press enter, and there's our speed. All right. So according to this, 119 miles per hour would be our third quartile of Nadal's surface. Okay. So that's today's video on performing normal calculations. I know I went pretty fast through that, but I wanted to try and get the video done as quickly as we could. As always, complete the video form below, and know that when we get to class together to cover this material, we'll have lots of time to go through examples and then give you time to practice, because practicing with your graphing calculator is going to be extremely important for this section. All right, well, thanks for listening, and I hope you guys have a great day.